Welcome everybody to today's topic of ergonomics and human-centered design, where we think about design in terms of allowing nature to dictate our work. You can see the structure of our lesson for this section of learning. The first quarter we'll be looking at ergonomics as a theory, and when we come back together in class we'll be completing a design exercise, back to some theory on ergonomics concepts, and then into our design exercise part 2. So we'll begin with the question of what is human-centered design. When we think about human-centered design, we consider designing for humans. We can break that into 3 subtopics: ergonomics, human factors, and usability. All of these can be applied to areas of industrial design, architecture, town planning, and even technology design, app design. So the Latin breakdown for ergonomics: ergo means to work, and nomics means the natural law. So how can we make objects or places work that fit into our natural law? By definition, ergonomics is the application of scientific information concerning humans, the design of objects, systems, and environments. We're looking for how these interact to optimize human well-being and overall system performance. Traditionally, during the Industrial Revolution, when a lot of products and buildings came to be at the forefront, everything was machine-centered. So we had new technologies, we could build steel, fabricate large places and mass production. However, our thinking then was about how can we make these components work together engineering-wise. So generally, we were using a machine-centered approach. You can see in this example of the Avro Lancaster bomber in the cockpit, this World War II plane is still machine-centered. It's very much based around what is the function that it has to perform, and compared to the plane design of now, it's very raw and simple in its construction. So we think about, what is design? Is design just a technical problem-solving exercise? No, it should be about people. We use this usability checklist when we consider designing for people. We think, is it functional? Does it work as it's intended? Is it reliable? Can I use it every time? Is it usable? Is it easy to use? Does it perform the tasks quickly? In this triangle, let's think of an example of the iPhone. So for most people, the iPhone has high personal significance. It works well. We generally think this is awesome. It's quite meaningful for us. It gives us pleasure, it's convenient, usable, reliable generally, and definitely functional. So, in adapting machines to people, we think about how are they functional, usable, elegant, beautiful, and emotionally engaging. In a conceptual model, we consider the human and their input. And then with the machine model, we think about it as an output. What does it need to do? Here is the interface. However, if we've got a goal, we can think about a conceptual model and the input, think about how we can execute that to work in machine logic, the output, and then evaluate that for the person. When the person is our priority, That's when we come up with good designs. The user's conceptual model is not the same as the machine logic or the designer's conceptual model. The feedback loops are essential for good interaction. Let's think about, how does this thing work? The feedback loop between action and result lets us think how useful and functional a product can be. So we have a goal, we consider it, we create a product. Ideally though, in a feedback loop is working effectively, we look at the conceptual model and the goal and the product. We work through an execution of the model to create the product, and then we evaluate it and go back to our goal. Has the product achieved our goal? So we can continue in cycles like this as we refine the product and make it better. Now we're up to iPhone version 10. So this has been through an example of the conceptual model many times. When we're designing for ergonomics, we look for something called product semantics. That is the language of the products, how we read and interpret the product's affordances and signifiers. Product semantics, in this example of the bin, you can see here we're considering how do we know how to use things. Here's a handle that suggests when we see it that we could use that to lift the lid. Here's a handle at the pivot point, which suggests when we need to drag this out to the curb, we can hold this way. So here we have an affordance. We know we can hold it here, or with the lid lift, we can hold here. We also have signifiers, which are like signals. They can be through a shape or a texture or a colour. This moves us into other objects. Consider when you handle other objects. In these examples, all of these products are doing a similar function, performing a similar function. They all use the pistol grip in some form. However, their handle designs are quite different from each other. In preparation for our design exercise, your task is to choose one handheld appliance. So it needs to be battery or cord electric operated. You can use these examples or you can choose your own. I'd like you to draw or find an image of the handheld appliance you're choosing, and then sketch 3 or more ideas for a new, more comfortable grip with clear semantics. Remember, our semantics are affordances and signifiers. How is the person going to know where to hold? What signifier will you use to suggest that's what they should do? Your turn now. Time to start sketching. Make your drawings at least 10 centimeters in size each on your page. Use your sketching skills to quickly iterate some examples of these. After that, when we come back together, we're going to make a 1-to-1 scale plasticine model of the best design you've drawn.